understand that too. So this particular problem is problem number 6. You can see this in the homework. And it's asking about some probabilities, and the event is selecting one card. So, and I'm going to, because I'm going to fix it so the names aren't taking up space here for me. So if you have a question, you might have to turn on your mic and actually talk, okay? I can see the chat for just a little bit, but I'm just letting you know that I may not, I can't see your hand raised, all right? So I can't see your hand raised, so I need you to either turn on your mic and talk to me or type in the chat, one or the other. So here we have, says we have a standard deck of cards contains 52 cards, and we've looked at that sample space before. And so it says one card is selected from the deck. Now what I'm going to work with you on is writing the probability statements and applying the formula. And most of these are OR probabilities. So let's just write the formula. I'm going to see if I can type it here. So there's the probability for an OR. So I want you to look at this very first question. And it says, find the probability of drawing a spade or a club. Remember, we're drawing one card from the deck. We want to know the probability of drawing that one card is a spade or a club. So following our formula for this A part, we would have the probability. So I'm going to use this over here. So this is going to be the probability. So this is our A and our B. So the probability of A is going to be the probability we draw a spade, plus the probability of B is the probability that the card we draw is a club, minus the probability that the one card we draw is a spade and a club. Now, in the deck, there are 13 spades and there are 13 clubs. There are 52 cards total. So when I do this, the probability of it being a spade, there are 13 spades out of 52 cards, plus the probability it's a club, there are 13 clubs out of 52 cards, minus this last question is saying, what's the probability that the one card you drew is both a spade and a club? Well, those two things can't happen at the same time. These two things are mutually exclusive. which means the probability of them happening, since they're mutually exclusive, there's no outcomes in common, the probability of a card being both a spade and a club is 0. So I don't need to do that part, the subtraction part. But it's useful to show it because at least I thought through. You should always think through whether or not there's an overlap. And then, so all I have to do is add these first two fractions. So 13 plus 13 is 26. And you keep the common denominator of 52. And then we're going to reduce. We're going to divide by 2 on the top, divide by 2 on the bottom. That's going to be as much as that reduces. Notice the instructions, though, say to round to 3 decimal places. So I'm going to need my calculator. And I'm going to divide. You guys do this with me. I'm going to divide 13 by, hold on a second, 13 divided by 26 is 0.5. Oh yeah, thank you, Cecil, of course. I can divide by 13, thanks. Is 1/2, thanks, Cecil, is 1/2, which is 0.5. So yeah, that's the answer to that one. And that's the answer we're going to put in because they told us they wanted a decimal. Is everybody ready? Let's go on to Kayla, do you have a question?
No, I'm sorry.
That's okay. I totally understand. Okay, guys, so let's erase this. Let's jump down to part C on this one, okay? So I'm going to do part C. This is actually just a picture. That's why I can't really put it in. This is a picture of the problem. So this says compute the probability. So I'm going to write the probability statement of selecting an 8 or a diamond. Unfortunately, I lost that nice little typed formula that I had, but we're going to follow that formula. So the first part is the probability that I draw an 8, or means to add. Then I'm going to have the probability that I get a diamond. Don't forget the minus part. Sometimes you need it and sometimes you don't. On this one, we're going to need it. So the last part is the probability that we've drawn an 8 and a diamond. Okay, so let's talk about these different things. First, let's talk about how many 8s there are in the deck. There are 4 outcomes that are 8s. 4 8s in the deck. On the diamond, there are 13 outcomes because there are 13 diamonds in the deck. So for these first two probabilities, remember when you're talking about a deck of cards, it's 52 for your bottom number. So since there are 4 8s, the probability of that the card we draw is an 8 is 4 out of 52. Plus, the probability that the card we drew is a diamond is 13 out of 52 because there are 13 diamonds. Minus, now let's look at this last one. The probability that the card we drew is both an 8 and a diamond. There's only one way that can happen. That's the 8 of diamonds. There's only one card that's both. But that is an overlap. That's one card that we counted in with the 8s, and we counted it in with the diamonds, so we counted it twice, so that one card, that's the 8 of diamonds, needs to be subtracted off, and it's still out of 52. All of your denominators are 52. So then that gives me, we're going to add and subtract across the top and keep the common denominator. So 4 plus 13 is 17, minus 1 is 16 out of 52. Those will both divide by 4. If I divide by 4, I get 4 over 13. That would be the exact fraction answer. And then since they want rounded to 3 decimal places, I need to do that. So 4 out of 13, or we could have done 16 out of 52. Either one would have given us the right answer. And if I round this to 3 places, it should be 0.30. That 7 needs to be rounded up to an 8 because the next number is 5 or bigger. So that's the approximate decimal probability. So about a 30%, almost 31% probability that if we draw a card from a deck, it's an 8 or a diamond. Does anybody have a question about that one? Okay, let's do another one. The next one that I pulled up for you is number 9. Now this one has a table on it. And so this is going to be getting these kinds of questions right comes from understanding your table. But I want you to know, hold on a second. Sorry, almost fell out of my chair. That was not good. Okay. Hold on just a second. So, I feel pretty silly. All right. So notice it says the table below shows the results of a survey that asked 1,047 adults if they favored or opposed a tax to fund education. And you select one person at random. Notice it's just one person. A person is selected at random, and it says complete parts A through C. Now, I took a picture of this, so I only have part A here. But let's look at part A. And then the other parts you can do on your own. So if you want to do this one, you can go to number 9. But this says, this one says, find the probability that the proposed person opposed the tax or is female. See the word or. That means we're going to use the addition rule. Remember our addition rule? So if we call this A and this B, then if I'm doing probability opposed to the tax or is female, then that's going to equal, let me bring this over here, it's going to equal the probability of A, so probability they opposed the tax, opposed, plus the probability of B, which is female, minus the probability of both, that they opposed and are female. Now, if you want to come up with symbols for stuff like this, that's a pretty good idea. Maybe call opposed, you could call that O or P for opposed, and female call that F. Then you don't have to write so many words. So I call this the probability that it's opposed plus the probability that they're female minus the probability they're opposed and female. Now let's see how we get these numbers off of a chart like this. First, the probability that they are opposed. So you're looking for everybody who is opposed. So look in the opposed column right here. We need everybody who's opposed. So that would be this total right here. So the probability they're opposed is 632 out of 1,047. Remember, that was our total number that they gave us at the start. So that's our denominator for all of the probabilities. Plus, let's do the females in a different color. So for this next one, they want the probability that they're female. So now we're looking at this right here. This row here is the females. And the total number of females is 564. So there are 564 females out of 1,047 surveyed, minus this last one. Now, if you do this on the chart like I've done here, not that you have to draw the chart, although that would be helpful, You can print it out though, if you happen to be hooked up to a printer. But if you notice here, the probability that they're opposed and female, that's going to be the overlap. That's going to be where my blue box and my red circle intersect. You see those? I'm going to do those in a different color. Let's do those in purple. You see this right here? That 308. Notice they're both in the opposed column and in the female row. That means that those 308 people, they got counted twice. That's how many of the people are both opposed to the tax, or that both opposed and female. There's 308 of them. Notice they're both in the opposed column and the female row. That's 308 out of the 1,047. I counted those 308 people twice. I've got to subtract them off once. Now, this gives me, I'm going to use my calculator for this. I'm going to set this down so I don't fall this time. This will be an interesting recording for people with me talking about falling. 632 plus 564 minus 308, and that gave me 888 out of 1,047. I'm not going to try to reduce that. It asks for a decimal to the nearest thousandth. That's 3 places, so I'm just going to take that 888 divided by 1,047. And to 3 places, that's going to be 0.848. The number after that second 8 was a 1, so I kept it. So they're going to ask you a couple more questions from this, but hopefully this one will help you. Does anybody have a question about this? I'm hoping this is starting to seem fairly easy to you. Any questions? Let's see. Okay. All righty. In that case, let's go to the next one that I had to share with you. And for this next one, let's see, this was problem, the one we just did was number 9. I think the next one I had to share with you is number 14. No, number 8. Didn't do number 8. I want to do number 8. This is actually the chart for number 8. So I'm going to have to pull up number 8 to get the question. But this is the chart that they provide on number 8. So I'm going to pull number 8 up on in my math lab. And the first question, and I'll come back to this circle graph so you can see it. But on number 8, the first question they ask is, it says, this is the estimated percent distribution of a certain country's population for 2025 in this pie chart. It says, find the probability of each event listed in parts A through D. And the first one says the probability of randomly selecting someone who is under 5 years old. So this is going to hit a lot of different top things that we've done so far in probability. So I like this a lot. So if you look at this right here, it says, it's just asking for the probability that someone is under 5 years old. Get my pie chart. And they want this as a percent. So do you see that it tells you, it says under 5 years is 6.5%. So the probability they're under 5, don't make it harder than it is. that percent is given there, 6.5. And since they have the percent sign out there outside of the box for you, don't put it inside the box or my math lab will count it wrong. So I'm just going to put in the box 6.5. Okay, maybe it's different on my chart. 6.4 on my chart. 6 point. I'm just getting it so I can see the next question. The next one says, what's the probability of randomly selecting someone who's 45 or older? So I could write that the probability that they're greater than or equal to 45 because it says 45 or older. So let's look at that circle graph again, that pie chart. And it says 45 or older. So notice there are 3 different pieces of pie that are 45 older. What do you think I should do with those percents to get the answer to this question? Add them, right. So if you guys add the probability, so just add those percents and tell me what you get. When you added those 3, so we have 25.7 plus 10.3 plus 8.5. Now these aren't going to be the answers to yours. I just noticed that they give you a different pie chart every time you do the problem. So you need to make sure that you look at your pie chart before you put answers in. So it's going to have different percents. But what did you guys get when you added those 3% on this particular pie chart? So you have to add those last 3 age groups, which I'll get. Make sure you bring your calculator to class. Anybody do it?
I got 44.5.
Okay, I think that's correct. Good job. So that one we got 44.5. I'm just going to put that up here. Don't forget that you're not going to put the percent sign in there. The C part says randomly selecting someone who is not 65 years old or over. Probability that they're not 65 or older. Not. That means we're looking for the complement. So I want to show this to you. So I wrote this, the probability that they are not 65 or older. Well, an easy way to do that would be to use the complement and say 1 minus, anytime you're doing the probability of a complement, do minus the probability that they are 65 or older. So let's see if we can get that number off of the pie chart. So here's the pie chart again. So 65 or older, notice that we're going to have to add 2 different, percents to get that probability. So 65 or older is going to be that 10.3. And the last age group of 75 or older is 8.5. And so when we do that, let's see, 18.8%. So this is going to be 1 minus 18.8%. Now keep in mind that 1 is 100%. So you can do 100 minus 18.8. Another way we could have done it is we could have added all the rest of them. That would be another way to do it. So instead of adding those two and subtracting from 1, we could have added up all the ones that were younger than 65. And that should have also added up to come to the same answer. And if I do it this way, though, using complements, I get 81.2%. And I need to do mine on here real quick so that so I can see what the last question is. So this one is just using the last question is pretty easy also. It's asking you the probability they're between two age groups. So you just have to make sure you add the right percents. So this particular problem, number 8, isn't really using the addition rule or the multiplication rule. It's just having you practice with probabilities and percents and complements. Okay? So that's number 8. And then I also I have a few more. I'm going to go ahead and work the ones that I have left. And if you need to go, that's fine. This will be on the recording. Because I feel like I should work a couple of these with you. If you have a certain one you wanted me to work, I don't mind staying on and doing that. But the next one that I was going to work with you is this one, which is number 9. No, we did this one. We did number 9. So let's do number 14. Okay. Let's just do one of these. On this one, this is number 14 from your homework. It says the data on the right represent the number of live multiple delivery births. By that, they mean 3 or more babies in a particular year for women 15 to 54 years old. Use the data to determine the following. First one says, determine the probability that a randomly selected multiple birth for women 15 to 54 involved a mother 30 to 39 years old. So they're talking about the probability that the age group is 30 to 39. Okay, notice that the age groups they have there, one of them's 30 to 34 and one of them's 35 to 39. So I'm going to need both of those. 30 to 34 looks like 2,831 people. And then the next one is 35 to 39 is 1,853 women. And then I'm also going to need the total. It doesn't look like it says the total. So can anybody tell me, how am I going to know what for the bottom number? Is there anybody left in the class that can help me with this? How do I get the bottom number for this? How do I know? I need to know the total number of women in this study. Now, when you're on this, it might give you the option to open it in StatCrunch, in which case you can figure it out using StatCrunch. I don't think it told us, right? No. So Okay, there's several of you left. How can I find the total? Because I need the total number of people if I am going to, so I'll know what the bottom number is. I know I need to add these. That's going to give me the total that are in this age group. So I'm going to have to add those two. But what number is going to go on the bottom here? How do I get that? Any ideas?
You add all of the numbers in the data.
Right. Good, Stephanie. Did you add them? Did anybody add them and get an answer? I did, but I want to make sure I added them right. You guys double check and so we can see if I added them right. You got 7397. I got 7404. So I need to double check on this. Did you, Stephanie, did you add the ones that are on my slide or did you add the ones on your problem in my stat lab? Did you add your problem or did you add the ones that you see on the screen right now? Because they probably add up different. I'm going to double check my numbers. So I had 90, 510, 1630, 2831, 1853, 378, and 112. Yeah, on mine, I double checked it. I got 7404. And so if I add, remember I added these two age groups to get the total that were between 30 and 39. And if I add those, you use yours, okay. That's fine. When I added those two age groups, I got that. And then if I divide by 7404, and they probably tell you to round to 3 places. I don't have this one pulled up, although I can pull it up. Number, I think this was 14. Round to 3 places, yeah. So on mine is 0.633 is what I would put in. You'll notice on this homework assignment that I put show work on a few. You won't miss it if you don't show work. The only reason I put show work on any of them, and actually I'm just talking to you, Stephanie, but the only reason why I put show work on any of them is so that you could practice showing your work in the show workspace. It won't count against you if you don't, but I wanted you to have the opportunity to practice before the next test. So Stephanie, you will know, and then those of you who are watching the recording, if you watched it to the end, then you'll know that the show work problems are just there so that you can practice using the type tool and using the draw tool. I prefer for you to use the type tool when you can because it's easier to read. I'm going to click on, let's see, on this one, if I click on show work. So Stephanie, since I'm talking to you, if you click on the show work, you'll see a little, one of the buttons looks like a pie. And that's another tool that you have if you want to do symbols. I haven't used it very much, but it will allow you, it may allow you to do fractions and stuff like that. Yeah, so it will open up. If you do the pie, then when you first do it, it gives you, there's like a box, and then there's a little thing on the box that looks like another box, and it says, it looks like this, pi, the radical plus. If you click on that, then it opens a set of tools. And some of those tools are parentheses, fraction, there's a fraction bar. So this gives you more tools for typing. So that might come in handy like when you're doing fractions and you're trying to type. Okay? Yeah. So if you want to play around with that, that's why I put those show work on there. I think I chose about 3 or 4 problems and I clicked for you to show your work. Like I said, it will not count against you. If you get the answer right, it's going to count it right. But that will give everybody an opportunity to practice getting better at showing their work neatly. That's the goal. So that on the next test, it will be easier for me to read your work. Did you have any questions, Stephanie? As long as you're still here.
I had a question about number 13.
In this assignment?
Yes.
Okay. Okay. So, number 13. I'm just going to look at mine. We can do yours if you want to. I'm just going to look at mine. Oh, that actually is similar to the one I was going to do, the last one, but I ran out of time. So I'm going to keep the recording going because it'll probably be useful to other people as well. So this one says, yours probably says the same thing. It says, find the probability. I'm going to write the whole question here. This is number 13. And I don't know, you can do yours. This is a really easy question, so I think just having an example, you're going to be fine. So when you see that EC like that, that's how I got this problem from another book. And that is the same thing as E prime, which means the complement of E. So this is a good question, and also this was the other thing I was going to show. So thank you for asking. And so if I want to find the probability of E complement, that's what that C stands for, is complement, then that's 1 minus the probability of event E. That's your formula, because the probabilities of an event and its complement always add up to 1. And so this one I'm going to have 1 minus, and they gave me that probability, 0.23, which is going to be 0.77, and that will be the answer. Probably not for yours. So Stephanie, yours was probably different, right?
Yes, it was.
Okay, but that's all you do, is you just subtract it from 1. So that's just a different notation. This was I had mentioned before, is that different books sometimes use different notations for complement. Personally, I kind of like the C a little better because it doesn't look like a 1. That's supposed to be an apostrophe. So I kind of like the C, plus it reminds me of what it is, that it's complement. So I like that a little better. But the book we're actually in uses E prime instead of EC. So that's why we have to learn both. Anything else that you'd like to go over?
Yeah, that's all. Thank you.
You're welcome. So good luck on doing your homework and getting it done over the weekend. Everybody try to get, if you can get all your homework caught up through 3.3, you're going to be in really good shape preparing for the next test. So I'll talk to you on Monday. We'll be in October. Have a great weekend.